Hello, my name is Renette and I'm an exploration geologist, and today I'm going to show you how to measure alpha and beta angles from diamond drill core. So we get two sizes of drill core. We start off when we collar a hole with a bigger drill bit, and that's called an HQ, and it's normally sort of that size. And then here, as we get further down the hole, the core is a little bit smaller, and that's called NQ, and that's around that size. These two tools I'm using here are called Kenometers, and I'm going to use these to measure my alpha beta angles. The first thing you have to be aware of is the orientation of the core and how the drillers place this into the box. So these lines over here, I'm going to remove this and take this into the shade so you can see. This line here with these arrows is an orientation line, and that was put on there when the hole was drilled and orientated. And this normally shows the bottom of the hole and which way is down. How this is orientated: as the hole is being drilled, a tool is being sent down the hole, and sometimes it's been marked there, or it's marked with various different tools that they use, and you can see, and then they pull it up, and when they pull it up, sometimes it gets rotated, but when it gets to surface, they have marked the bottom, and then they draw this line down there. So today we are going to measure this plane going around like here. Now, if you're wondering why this is making an ellipse, it's because this is a rounded surface, and this plane is cutting through the hole like that. And you can actually see, if this is the bottom of the hole and the hole was potentially drilled in that orientation, then this plane would have been intersected in that orientation. This is the orientation of this plane we want to get. So always remember, when you remove a piece of core from the core box, it's very important to keep track of where you've taken it from so that the core doesn't get mixed up. So we've removed our piece, and I'm going to show you now how you're going to do this. You can help. These features aren't often that visible, but you can help yourself by marking the feature with a marker. So you can trace it around like that, and then to find the dip, the maximum angle of the dip of this plane, you find the area where your ellipsoid has the largest inflection, so to speak, and you mark that down there. And if I follow this plane around the core, you'll see that it makes another ellipse on the other side, or the up dip side of the plane. So we're going to measure this here, which just happens to be very close to the bottom of our hole. So this is my actual dip there, and that's the orientation line. So here we go. Kenometer, and then you'll see on this kenometer, so you'll see here we'll have markings that show the beta angle going around like that, and the alpha angle marked like that. And on here is an arrow that shows you which would be down hole, so how to orientate your piece of core. If this is the arrow that says down hole, we want to make sure that we've got them in the same orientation. So here we go. Down hole, slide it in, and you take your mark from that ellipse that you've marked, and you put it on 0 there. Then you read how many degrees it is off towards the orientation line, and you can see for us here it's only about 5 degrees. So your beta angle, or the dip of your plane, is only really 5 degrees off the bottom orientation of the hole. So 5 degrees there. Then we turn it to the side, and we find a plane which matches our reading here. And you can see the closest kind of to our orientation here is this line here, and that's about 30 degrees, and that would be your alpha angle. And there you go.